Hello, and welcome back to AI Ed from Bits to Breakthroughs. I'm your host, Vanessa 2.0, one of the AI-generated avatars here at newbits.ai. Thank you for joining us again in our AI Basics, the Fundamentals series. In our previous episodes, we introduced this series and explored the history and evolution of artificial intelligence. Today, we're going to focus on understanding the basics of AI. We'll break down key concepts and common terms that are essential for anyone looking to get a solid grasp of AI. By the end of this episode, you'll have a better understanding of the three main components of AI: machine learning, neural networks, deep learning, and natural language processing models. These components form the foundation of modern AI systems and enable AI to perform a wide range of tasks, from image recognition to language understanding. So, let's get started. Let's begin with the most fundamental question. What is artificial intelligence? Artificial intelligence, or AI, refers to the simulation of human intelligence by machines. AI systems are designed to perform tasks that would normally require human intelligence, such as recognizing speech, making decisions, or understanding visual information. AI is often categorized into three main types: narrow AI, weak AI. This is AI that is designed and trained for a specific task, such as facial recognition or recommending products based on your past purchases. Narrow AI is the type we interact with on a daily basis, from virtual assistants like Siri and Alexa to the algorithms that curate your social media feed. General AI, strong AI. This type of AI, which remains theoretical, would have the ability to understand, learn, and apply intelligence across a broad range of tasks, essentially mimicking human cognition. We haven't reached this level of AI yet, and it remains a topic of research and debate. Super AI. Super AI refers to a level of intelligence that surpasses human intelligence. It would be capable of outperforming humans in nearly every cognitive task, including scientific creativity and general problem solving. Although it's often discussed in theoretical terms and depicted in science fiction, super AI is something that researchers are considering in the long-term future. Now let's dive into the three main components of AI. 1. Machine learning. 2. Neural networks, deep learning. 3. Natural language processing, NLP, models. These components work together to form the core of modern AI technologies. Let's explore each one in more detail. First, machine learning is the backbone of AI. It enables computers to learn from data rather than being explicitly programmed for specific tasks. In machine learning, algorithms analyze data, learn from it, and then make predictions or decisions based on that learning. This process allows AI systems to improve over time as they process more data. There are three main types of machine learning. Supervised learning. In this method, the algorithm is trained on labeled data. For example, if you want to build a model that recognizes cats in photos, you would feed it thousands of images labeled cat or not cat. Over time, the algorithm learns to identify patterns and make accurate predictions on new, unlabeled images. Unsupervised learning. Unlike supervised learning, this method works with unlabeled data. The algorithm tries to find patterns or groupings in the data. A common application is customer segmentation, where unsupervised learning helps businesses group customers based on purchasing behavior without predefined labels. Reinforcement learning. In reinforcement learning, an AI agent learns to make decisions by interacting with its environment and receiving feedback in the form of rewards or penalties. This approach is not limited to just robotics, gaming, and autonomous systems. It's widely used across many AI categories, such as language, data, audio, vision, and even healthcare. By adapting and learning from feedback, reinforcement learning has the potential to revolutionize these fields by improving the AI's ability to learn complex tasks. The second component, neural networks, forms the foundation of deep learning. Neural networks are computational models that mimic the structure of the human brain, and they consist of layers of interconnected nodes or neurons. These neurons are organized into three main types of layers: the input layer, the hidden layers, and the output layer. The input layer receives raw data. The hidden layers process that data by performing mathematical transformations. The output layer produces the result or prediction. Neural networks work by adjusting the weights between neurons during training, allowing the system to learn complex patterns in the data. The deeper the network, meaning the more hidden layers it has, the more capable it is of identifying intricate patterns and relationships. This is why deep learning is particularly effective for tasks like image recognition, speech processing, and natural language understanding. For example, deep learning models are behind the facial recognition software used in smartphones and the speech-to-text engines in voice assistants like Siri and Alexa. The third component of AI is natural language processing, NLP, which enables AI systems to understand and generate human language. NLP is essential for tasks like speech recognition, text generation, and language translation. With NLP, machines can interpret, process, and respond to text or spoken words in a meaningful way. Some common applications of NLP include chatbots and virtual assistants. AI-powered assistants like Siri, Alexa, and Google Assistant use NLP to understand spoken commands and provide relevant responses. Text generation and translation. Models like GPT-3, developed by OpenAI, can write human-like text, translate languages, and even hold conversations. NLP has revolutionized how humans interact with machines, making communication between humans and AI systems much more seamless and natural. Let's not forget the importance of algorithms in AI. In the context of AI, an algorithm is a set of instructions or rules that the system follows to make decisions or predictions. Algorithms form the backbone of any AI system, and the quality and effectiveness of the AI often depend on the strength of the algorithm. For example, recommendation algorithms help platforms like Netflix or Amazon suggest movies or products based on your past behavior. In natural language processing, algorithms enable systems to translate languages or generate human-like text. It's important to remember that AI's performance is directly tied to the quality and quantity of data it is trained on. The more relevant and accurate the data, the better the AI system performs. Speaking of data, let's briefly touch on why data is so critical to AI. In a nutshell, data is the fuel that powers AI. AI systems rely on vast amounts of data to learn, make decisions, and improve over time. Whether you're talking about supervised learning, unsupervised learning, or deep learning, none of it would work without data. AI systems are particularly powerful when they have access to big data, datasets so large and complex that traditional data processing methods can't handle them. The more data AI can access, the more accurate and sophisticated its predictions and actions become. Now that we've covered the three main components of AI, machine learning, neural networks, deep learning, and natural language processing, NLP, you should have a clearer understanding of how AI works and why it's so powerful. At newbits.ai, we offer a wide range of AI tools and solutions to help you dive deeper into these concepts. Whether you're interested in experimenting with machine learning algorithms, exploring deep learning models, or leveraging natural language models, our AI Solutions Directory has everything you need to get started. From AI tools to comprehensive platforms, you can explore models that align with your project goals and industry needs. In our next episode, we'll explore the different types of AI, narrow versus general versus super AI, and what distinguishes each type. Thank you for joining me for this episode of AI Basics, the Fundamentals. And as always, stay curious, keep exploring, and remember, it's all about the bits, especially the new bits.